Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something.
Nice to see you again in this machine learning class. In this class, let's move on to learn what is the classification algorithms. Let's quickly begin with the concepts of classification algorithm. Let's talk about some issues with clustering algorithms based on partitioning. Classification is about assign new data points to existing categories. This process is also known as supervised learning, which is different from unsupervised learning, like clustering. However, this type of classification is not suitable for identifying clusters with non-convex shapes. So, what's the solution in such cases? You might consider using density-based clustering method, but we can make use of a new approach, which is the classification algorithm. From the figure, we can observe that this dataset consists of 4 feature attributes and 1 class attribute. Therefore, based on whether the samples are accompanied by labels, we can refer to the samples with labels as unsupervised learning. In this case, our task is to determine whether a given sample is a mammal. To achieve this, we've employed a set of features to serve as an indicator of whether the sample is a mammal. These features include factors like being viviparous, having the ability to fly, residing in water, and persisting lakes. Our goal is to establish a functional relationship between these features and the target, in order to create a model that can discriminate whether the sample is a mammal. Let's consider another example. In this case, our objective is to determine whether a person will commit tax evasions. We utilize 3 features: whether they paid taxes last year, their marital status, and their taxable income. It's important to note that in a classification task, the objective is always a categorical variable. Here, the question of whether tax evasions occurs or not represents a categorical variable. Now let's delve into the general steps of classification algorithm. We have an example here concerning the classification of animals as mammals or birds based on a series of features. In this table, the first 6 rows represent samples with no label, while the 7th and 8th samples have unknown labels. Our goal is to learn a certain relationship or function from the first 6 levels, and then apply this relationship to calculate the unknown levels for the 7th and 8th samples, determine which category they belong to. In this case, the first step typically taken by a classification algorithm is to transform the samples into features of the same dimension. Put simply, this means that all the samples should possess the same number of meaningful features, and these features should be both relevant and independent of each other. Moving on to the second step, we need to select the features that are relevant to our classification task. In other words, these are features that intrinsically contribute to our task. In this example, the features highlighted in green are useful ones, while those in black are irrelevant. This is quite straightforward to understand. Features like wingspan for birds and the size for mammals are much more informative than some of the size-related features for dogs and cats. Some large mammals like elephants and tigers are considerably larger than birds, so these size-related features don't contribute much to the classification task. In the third step, we establish a classification model, often referred to as a classifier. A classifier typically represents a mapping from a feature space formed by a set of features to a target space. In other words, it's a set of functional relationships, just as depicted by this formula. In the fourth step, we utilize this established model to predict the categories of unknown samples. Here, we apply the classifier
model we built based on the previous samples
to predict the categories of these two unknown animals. In the next step, we use various evaluation metrics to assess the performance of our model's prediction. The common evaluation metrics are illustrated in this graph for your references. Let's emphasize the distinctions between classification and clustering once again. In classification tasks, there are labels that serve as mapping between features and targets. However, in a clustering task, labels are absent, and our focus is solely on learning underlying patterns from a series of features. Indeed, there are numerous classic and well-established models in the realm of classification algorithms that can be applied across various scenarios. Some of these classic classification algorithms include KNN, logistic regression, Bayes decision trees, and random forests. To summarize today's lesson, we covered the concepts of classification algorithms and delved into the general steps involved in these algorithms. We then highlighted the distinctions between classification and the clustering, covered in the previous chapter. Lastly, we introduced several classic classification algorithms for you. So, this concludes today's course, and we will see you again in the next course.